Hello there, welcome to this tutorial, and the topic is systems of equations and the method is Gaussian elimination method. I still remain your tutor Abdurrahman Umar, and remember to subscribe to our YouTube channel Uninab Resources and like this video. Here we go. We have to solve the system of the equations x1 plus 2x2 minus 3x3 is equal to 3, 2x1 minus x2 minus x3 is equal to 11, 3x1 plus 2x2 plus x3 is equal to -5. Here the method still remains Gaussian elimination. We are going to form the augmented matrix of the system, which is the collection of the coefficients of the variables including the constant. So the matrix, from the first equation we collect the coefficients to form the first row, so that's going to give us 1, 2, -3, and then 3. This line is representing equal to there. We go to the second equation to form the second row. The coefficients there are 2, -1, -1, and the constant is 11. The third equation, we use the coefficient of the third equation to get the third row. So we have a 3, 2, 1, and the constant there is -5. So we have generated the augmented matrix. So we are going to reduce this matrix to row echelon form. So by doing so, the leading diagonal will be 1, 1, 1, and all the elements below will be reduced to 0 using some elementary row operations. So let's go. Now we wish to reduce this 2 to 0. To do that, we are going to maintain the row 1, row 3 for now, but the row 2 will now become row 2 minus 2 row 1. We multiply this 1 by 2. By the time we subtract to get row 2, this will become 0. So let's go. We have 2, -1, -1, then 11. That's row 2. So we now multiply row 1 by 2. So multiply by 2 gives 2, 4, 6, and 6. We subtract. So in our subtraction, we have our new matrix maintaining row 1. The row 2 now becomes 2 minus 2 gives 0, -1 minus 4 gives -5, -1 minus -6 will give us a +5, and 11 minus 6 gives 5. Here again we still maintain row 3. So this is our new matrix. Again we go further to reduce this to 1. We make this -5 1. Having done that, we will now reduce this 3 to 0. So to do that, we said row 2 becomes row 2 divided by -5, and row 3 will now become row 3 minus 3 row 1. So we multiply row 1 by 3. Since when you multiply this by 3, 3 minus 3 will give us 0. So we go. So starting from the second row now, we maintain the first row. So the row 2 becomes row 2 divided by -5. 0 divided by 5 gives 0. -5 divided by -5 gives 1. 5 divided by -5 gives -1, and 5 divided by -5 gives -1. And our row 3 now becomes row 3 minus 3 row 1. So our row 3 is there, 3 2 1 negative 5, and now 3 row 1 multiplying row 1 by 3, we have a 3 6 negative 9 and 9. Again, we are going to subtract. In our subtraction, 3 minus 3 gives 0, 2 minus 6 gives negative 4, 1 minus negative 9 gives 10, and negative 5 minus 9 gives negative 14. So we now have our new matrix again, and here we shall now reduce this negative 4 to 0, carrying out our elementary row operation. We can now have row 3 to become row 3 plus 4 row 2, and since this is negative 4, by the time you multiply this by 4, add them, this becomes 0. So what we do now is row 3, where's row 3? Row 3 is 0, negative 4, 10, negative 14. That's minus, we're adding 4 row 2. We multiply row 2 by 4. That will give us 0, 4, negative 4, negative 4. Then we add. So in our addition, the new matrix we are going to have, we maintain row 1, we maintain row 2, and the row 3 now becomes row 3 plus 4 row 2, which is the result we are going to obtain from this operation. 0 plus 0 gives 0, negative 4 plus 4 gives 0, 10 plus negative 4 gives 6, and negative 14 plus negative 4 gives negative 18. And again, we have reduced this to 1, 1. We need to make this 1. So row 3 now becomes row 3 divided by 6. Row 3 divided by 6 here. So that we now have row 1 is maintained, row 2 is maintained, and row 3 will have 0, 0, since 0 divided by 6 gives 0, 6 divided by 6 now gives 1, negative 18 divided by 6 gives negative 3. So we have succeeded in transforming this main matrix to row echelon form. So this implies here that this is the coefficient of x3 this time around, and this is the constant. So which means x3 is equal to negative 3. Also, this is x2 minus x3 is equal to negative 1. Since we have gotten x3 to be negative 3, we now have it as x2, negative negative gives positive, so plus 3 is equal to negative 1. Taking this to this side, it becomes minus, so x2 becomes negative 4. And lastly, the first row implies x1 plus 2x2 minus 3x3 is equal to 3. So we need x1, and since x2 is negative 4, 2 times x2 gives negative 8, and negative 3 times negative 3 here gives positive 9 is equal to 3. So if we solve this equation here, that this negative 8 plus 9 gives 1. So the one going there, x1, is equal to 2. So with this, we have done justice to the first problem on Gaussian elimination method of solving systems of linear equations. So we go to the second problem. In the second problem again, we are going to form the augmented matrix. Forming the augmented matrix, we collect the coefficients of the variable and the constant. So the first row is the collection of coefficients of the variables in equation 1. So we have a 2, 1, negative 2, and the constant is a 9. So to get the elements of the second row, we collect the coefficients of the variables in the second equation, including the constant. So the coefficient of x here is 3, coefficient of y is negative 1, coefficient of z is 1, and the constant is 3. So the last row, which is the third row, is the collection of the coefficients of the variables in the third equation and the constant. So the coefficient of x here is 1, coefficient of y there is 2, coefficient of z is 3, and the constant there is negative 2. So we have formed the augmented matrix of the system. Again, this leading diagonal will be made 1, and the elements below the leading diagonals will be reduced to 0. With that, we have a row echelon form after some elementary row operations on the matrix. So we start with 3. We start with this entry, so that row 2 becomes 2 row 2 minus 3 row 1. So we have 2 row 2. What we are doing here is we are multiplying row 1 by 3 and multiplying row 2 by 2, so that when we find their difference, it gives us 0 here. So we go 2 times row 2, so 2 times 3 gives 6, 2 times negative 1 gives negative 2, 2 times 1 gives 2, and 2 times 3 gives 6. So, and row 1 multiplied by 3, 2 times 3 gives 6, 3 times 1 gives 3, and negative 2 times 3 gives negative 6, and 9 times 3 gives 27. We carry out the operation there, which is minus. In that case, we still maintain row 1. We maintain row 1, so row 2 now becomes the results obtained from the operations here. So 6 minus 6 gives 0. Negative 2 minus 3 gives negative 5. 2 minus negative 6 gives 8. And 6 minus 27 gives negative 21. And again, we maintain row 3 for now. And we have done that. We're going to use a different approach in this problem. So we are going to leave out the elements in the leading diagonals for now. So our next target now is to reduce this one to 0. So to do that, row 3 now becomes 2 row 3 minus row 1. We multiply row 3 by 2. By the time we subtract it from row 1, we'll get this to become 0. So 2 times row 3, so 2 times 1 gives 2, 2 times 2 gives 4, 2 times 3 gives 6, and 2 times negative 2 gives negative 4. And row 1 has 2, 1, negative 2, and 9. And the operation is minus. So we subtract. We said we are maintaining row 1. We still maintain row 1. Also, we maintain row 2. So row 3 now becomes 2 minus 2, 0. We have 0 here. 4 minus 1 gives 3. And 6 minus negative 2 gives 8. And negative 4 minus 9 gives negative 13. So we proceed again to reduce this 3 to 0. So to reduce this 3 to 0, so root 3 becomes 5 root 3 plus 3 root 2. This is 5. We are multiplying this 5 by this 3 and multiplying this 3 by this negative 5. By the time we add, this 3 becomes 0. So we go, this is 0. So we go 5 root 3, that is root 3 multiplied by 5. 0 times 5 gives 0. 3 times 5 gives 15. 8 times 5 gives 40. And negative 30 times 5 gives negative 65. And root 2 multiplied by 3, 0 times 3 gives 0. Negative 5 times 3 gives negative 15. 8 times 3 gives 24. And negative 21 times 3 gives negative 63. And the operation here is addition. So we are going to add. So our first row is maintained, the second row is also maintained, and the third row now will be the result from this operation. 0 plus 0 gives 0. 15 plus negative 15 gives 0. 40 plus 24 gives 64. And negative 65 plus negative 63 will give us negative 128. From here now, we can reduce this to 1, 1, 1. So which means the first row is going to be divided by 2. The second row will be divided by negative 5. And the third row will be divided by 64. So here we go. So from the first row, 2 divided by 2 gives 1. 1 divided by 2 gives half. And negative 2 divided by 2 gives negative 1. And 9 divided by 2 gives 9 over 2. We go to the second row. Second row will become root 2 divided by negative 5. So 0 divided by negative 5 is 0. Negative 5 divided by negative 5 gives 1. 8 divided by negative 5 gives negative 8 over 5. Negative 21 divided by negative 5 gives 21 over 5. And the third row divided by 64. 0 divided by 64 is 0. 0. 64 divided by 64 gives 1. And negative 128 divided by 64 gives negative 2. We have succeeded in reducing the main matrix to row echelon form. So the elements in the leading diagonal are 1 each, and the element below it has been reduced to 0. So we go further to find the values of x, y, and z. So from here, it implies the coefficient of z here is 1, so which implies z is equal to negative 2. And coming to the second row, the coefficient of y is 1, that of z is negative 8 over 5, and the constant is 21 over 5. So it means y minus hz over 5 is equal to 21 over 5. So y will be equal to 21 over 5. And since this guy is going to the other side, it becomes positive. Multiplying 2, we have negative 16 over 5. So 21 minus 16 gives 5. 5 divided by 5 is 1. So y is equal to 1. And finally, the first equation means x plus y over 2 minus z is equal to 9 over 2. So x will be 9 over 2. This is 1 over 2. Going to the other side, it becomes minus 1 over 2. This is plus z at the other side, and since z is negative 2, that will be minus 2. So 9 over 2 is 4.5. 4.5 minus half is 4. 4 minus 2 gives 2. So x is equal to 2, which brings the conclusion of the solution of this problem to an end. This is the end of the tutorial on Gaussian elimination method of solving systems of linear equations. Thank you for watching this video. Remember to subscribe to our channel at Oninab Resources on YouTube. Bye.